again, and I'm sorry again. The dryer's on again. Sorry, but we're washing a lot of clothes these days. Anyway, we're up to 1.6. We're going to calculate slope on a coordinate plane. Coordinate plane. These are coordinate planes. There's two of them here. Let's just focus on one here. So I'm sure you remember this. You put points on here, right? Going to give you some terms that you may or may not remember. You know what this line's called? This line, let me highlight it for you. This line right here. What's that horizontal line called right there? That is called the x-axis, right? The x-axis. How about the up and down line? This line right here. Whoa, gosh, I'm all over the place. What's that line called right there? That's terrible. That is called the y-axis. So this is an axis and this is an axis. Since you have two of them, you have two axes. I know it looks like axes, like chop, 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 but these are actually two axes. One axis and another axis makes axes. All right, what else can we talk about? How about each one of these sections? You see we kind of have four sections here. We got this section here. We got this section here. We've got this section here. We got this section here. And we've got this section here. Very beautiful. Each of these sections has a different name. They're not very creative. They're called 1, 2, 3, 4. And each one of them is called a quadrant. So this is a quadrant here. And a quadrant here. And a quadrant here, and let me skip ahead. There we go. So what are the names of them? As I said, 1, 2, 3, 4. So what do you think? One right here, right? No! This is quadrant 1 there. Why would they put 1 there? Well, I'm not positive, but I think I know why, and I'll tell you in a second. This is 2. This is 3. And this is 4. Okay? There's a very important point right here. This point right here is called the origin. The origin. What's origin mean? It means beginning, right? If the origin of something's the beginning, that's good because when we're going to name points, we kind of start here. All right, if we're going to name any point, right, whether it was this point or this point or this point or even this crazy point here, we would start here. And how many numbers would we need to name the point? We'd need to have two numbers to name the point, wouldn't we? So, for example, if we were going to name this point here, let's start with this one. First of all, you're going to count left, right, side to side, right? So to line up with that point, you're counting over 1, 2, 3, 4, 5, 6, 7. So the first number is 7. You're going to put it in brackets, 7. So over to 7, and then you go up 1, 2, 3, 4, 5. So this point right there is 7, 5. This is called an ordered pair. Obviously it's a pair because there's two of them, and it's an ordered pair because order matters. 7, 5 is a lot different than 5, 7. Maybe in a second we'll graph 5, 7, and we'll see it's a lot different than 7, 5. Well, what the heck, we can do it right now. Let's graph 5, 7. So if you're doing 5, 7, you would start at the origin, you would go left, right, 5, so that'd mean right 5, 1, 2, 3, 4, 5, and then you would go up 7. So over 5, don't put a dot though, don't put a dot until you also go up 7. 1, 2, 3, 4, 5, 6, 7 is right here. There's where 5, 7 is. So you can see 7, 5 and 5, 7 are a lot different. Order matters. That's why it's called an ordered pair. All right, let's tackle this point right here. What's that point? Well, you start at the origin and you go 1, 2, 3, 4, 5, 6, but it's not positive 6 because that'd be way up here. It's negative 6. This is a negative direction. This is a positive direction. So this point here is at negative 6, and then you have to go up, so that's a positive direction. 1, 2, 3, 4. So it's negative 6, 4. Good. Next point I want to do is this one right here. So again, you're going in a negative direction, 1, 2, so it's at negative 2. But then you're going down. That's also a negative direction. Up is positive, down is negative. Right is positive, left is negative. So we were at negative 2, and then we came down 1, 2, 3, 4, 5, 6, 7. So negative 2, negative 7 is that point. The last one, let me just change it a bit. Let me put it right there, okay, instead. Okay, so for that point, what do? You have to come over to 1, 2, 3, 4, 5, right? It lines up perfectly with the 5, so it's at 5. And then you have to come down 1, 2, 3, 4, 5, 6, 7. Well, it's more than 7, but it's less than 8. What's between 7 and 8? I'd say 7.5. But look, it's negative, so you're going negative 7.5. Okay? Now, what I want you to notice is that each one of the quadrants, the types of numbers are very different. In the first quadrant, quadrant 1, all the numbers you get are going to be positive. So you're going to have positive for the first number and positive for the second number. I think this is why it's called quadrant 1, because it's kind of like the most basic quadrant. Everything's positive in there. This quadrant, you're going to have a negative number first, and then you're going to have a positive number second, right? Just like we have there. This quadrant, number 3, they're both negative. Negative, negative. Negative 2, negative 7. And in this quadrant, you're going to have a positive number first, and then you're going to have a negative number after that. All right, let's just practice graphing a few more points. How about we'll do 4, negative 3. We'll do 7, 0. We'll do negative 2.5 and negative 6. And we'll do 0, negative 1.5. All right, so, and I'm going to call this one A, B, C, and D, because then we can put an A, B, C, D on here. So let's start with A. 4, negative 3. So remember, we always start at the origin. You have to crawl before you climb. Think of a baby. Baby has to crawl left, right before it can climb, go up and down. So go left, right first. All right, so we're going to go 4 in the positive direction. 1, 2, 3, 4. We do not put a dot there. If you do this, you're going to mess up, right? Because you still have to go down 3. So you're going 4 to the right. 1, 2, 3, 4. And then you're going down 3. 1, 2, 3. Here is point A right there. Okay, B. 7, 0. Well, that means start at the origin, go 7 to the right, 1, 2, 3, 4, 5, 6, 7, and then how do I move up and down? I don't. It's a 0. You don't move up and down. This is the point. So that's our point B right there. C, negative 2.5. Okay, we're starting with this direction, right? And it's negative, so we're going to the left. We're going over negative 1, negative 2, and another half, so we're right there. Don't put a dot, though. We still have to go down 6. It's negative 6. So negative 2.5 is here, and then down 1, 2, 3, 4, 5, 6. This is point C. And the last one, D. 0. So what does that mean? That means don't go left, right. Just stay exactly where you are. Stay there. And then go down 1.5. 1.5. So that is point D. By the way, back to the origin. What's the ordered pair for the origin? It's 0, you don't move in this direction, don't move left, right, and then 0, don't move up and down either. So the origin's the point 0, 0. All right, so now what we're going to do is we've got some lines, and they're on a coordinate plane, and we're going to find the slopes of these lines. It actually turns out for this first one, there's nothing different than what we did before, right? How did we find the slope of a line before, even if it wasn't on a coordinate plane? We just took a look for the slope. We needed to use rise over run. So here's our 2 points. You could use other points if you want, any 2 points, but since they show us those 2 points, we might as well use them. And we're going to draw a little triangle, right, for the rise and the run. So from this point, I would have to rise up to here, and then I would have to run over to there. So all I have to do is count what's the rise and what's the run. So let's do it. The rise. Don't count this number. Oftentimes people do this. They go 1, 2, 3, 4. No, you're starting here and you're going 1, 2, 3. And then you're starting here and you're going 1, 2, 3, 4. So there you go. There's your rise. There's your run. So the slope is equal to 3 over 4. That's great. If you want to put it as a decimal, you can. You don't have to. I just leave it like 3 over 4. But you could certainly put it as 0.75 as well. All right, here's our next one. Whoa, look at how far apart those points are. We could find some other points that are closer together. Like I think this is a point, and 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 this is a point. And any 2 of those will work. You don't have to use the ones that are far apart as they show. But we can. But what the heck? Let's do it. All it means is we'll probably have to put it in lowest terms when we find it. If you took points that were really close to each other, like side by side, like these, hey, we could do this too. Let's also find this one. Okay, so if I start here, slope, rise over run. Okay, 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you get the slope is 8, that's the rise, over 16, and you're done. But you should put it in lowest terms. What goes into 8 and also goes into 16? 8! 8 divided by 8 is 1, and 16 divided by 8 is 2. Okay, if we just look at this one, what's the rise? 1. What's the run? 1, 2. 1 over 2. Oh yeah, we get the same thing. See, it doesn't matter which 2 you would use here. You would all, if you put them all into lowest terms, you'd always get 1 over 2. Now, listen carefully. I've actually skipped something here, which I need to make a very important point here. There's something very distinct about this line right here. Does it not look a lot different than this line? It's of a different type. You know what I'm talking about? This line is going upwards. This line is going downwards. This here is a positive slope line. So 0.75 or 3/4 is absolutely correct. This here is a line that's going downwards. It's negatively sloped. Our answer should actually be not 8 over 16, but negative 8 over 16. Not 1/2, but negative 1/2. Now, the way I usually do this is just worry about it at the end. I get my slope and then ask myself, is this a positive slope or a negative slope? Well, it's going up, so it's positive. And I find this one, I find the slope's 8 over 16, and then I go, is that going up or down? It's going down, so it's negative. But here's the other way you could do it. When I did this counting here, I counted up, which is a positive motion. Remember, going up on the coordinate plane is positive. So this is positive 3 if you want, or just 3. And then I moved to the right 4, which is also a positive move. So I have a positive divided by a positive, which is positive. But when I did this one, I moved down 8, right? I started counting here and I went 1, 2, 3, 4, 5, 6. Well, that's actually a negative move. And then I moved to the right after that, which is a positive move. So really what I did is a negative divided by a positive, which gives me a negative overall. So you have to get used to the idea that lines that move in this direction, like this, or I don't know, really steep lines, or not very steep at all, but a little bit, these are all positively sloped lines. But lines that go down like this, really steep like this, these are all negatively sloped lines. The way you should think about it is, in cartoons and stuff, they show the people in the boardroom looking at profits. Profits are going up and down. And if they showed profits going up like this, you would say, wow, that's a positive thing. That's good. That's positive. But if your profits were going up and down and then did this, going way down like that, that'd be a negative thing. So that's negative slope. Okay, so you got to get used to remembering that this is negative slope like that. All right, so we're going to graph this line and then find the slope of the line. Okay, so let's do that. The first point we have to graph is negative 4, 3. So we start at the origin, negative 4, so that means go to the left, 1, 2, 3, 4. Don't put a point yet because we still have to go up 3. 1, 2, 3. So there's our first point right there. Second point, 6, negative 7. So we're going to the right 6. That's a positive direction. 1, 2, 3, 4, 5, 6. Don't put a point because we still have to go down 7. 1, 2, 3, 4, 5, 6, 7. There we go. Those are our 2 points. So now what I'm going to do is I'm going to join them with a line. Okay, there we go. Now you can see this line goes through a whole bunch of points, but it is kind of hard to know for sure which points it goes through. The 2 points I do know it goes through for sure are the 2 points I already drew. So why don't we use that to draw our triangle for our rise and our run. Now, before I do anything, you should be able to tell me, is this red line here, is that a positive slope line or a negatively sloped line? It is a negatively sloped line. So if you want, don't even worry about like negative movements and positive movements. Just say right off the bat, my slope is negative. But if you do want to look at your negative movements, you could start here You're going to count the run. Sorry, you're going to count the rise. I'm sorry. You're going to count the rise. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you see how I moved down? I moved down 10. So that's negative 10. Then I move to the right, which is positive. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, it's 10 this way. And that's a positive move. Now, personally, I don't like doing negative 10, 10. I just put 10 and 10 and then just think to myself, oh, it's a negative slope, so I know my answer is going to be negative. But you can also do it this way and say negative 10 over 10. Well, wait a minute. Negative 10 over 10. What's 10 divided by 10? Anything divided by self is 1. So actually, our slope is just negative 1. I'll put it down here. The slope is negative 1. Maybe now is a good time to tell you that slope is often indicated with the letter m. Weird, eh? So m equals negative 1. So m is the slope. Why is it m? Not really a good explanation for that. I've read a few things and then I've seen the same things refuted. There does not seem to be any agreement why m is often used for slope. Okay, last thing. We've talked about lines that have positive slopes, like this. Don't draw this. I've talked about lines that have negative slopes, like this. What I haven't talked about is lines that are perfectly horizontal and lines that are perfectly vertical. So we should probably talk about those. What happens with those? So let's start with a horizontal line. So what we're going to do is we're going to pick any 2 points we want on here. I don't know. It doesn't matter. How about this and this? It really doesn't matter which 2 you pick. And to get the slope, we have to calculate the rise divided by the run. So let's start at this point. How much do I need to rise to get to that point? I don't need to rise anywhere. I'm already at that point. So the rise in this case is 0. Now, how much do I need to run? I got to run 1, 2, 3, 4. So I get 0 over 4. What's 0 divided by anything? If I have nothing and I divide it into 4 groups, how much is in each group? Nothing. And this will always be the case, that for the slope of any horizontal line is always 0. Okay, that's always going to be the case. All right, let's take a look at this one, a vertical line. So again, let's take any 2 points. It doesn't matter. I'll do this one and this one up here. So slope equals rise over run. So let's get the rise. So start at either one of these points. I'll start down here, and I'm going to go up, which is a positive move. 1, 2, 3, 4, 5. So our rise is 5. How much do I need to run? I've risen 5 to get here. Well, I'm already at the point. I don't need to run anywhere. If I run anywhere, I won't be at the point anymore. So we're going to have 0 on the bottom. Now here's a tougher question. What's 5 divided by 0? You can't divide anything by 0. You're not allowed to divide by 0 in math. We can go over in class Y. I don't want to go into the whole song and dance about it right now. But what you're going to do is you're going to say it is undefined is what that means. So you can put this symbol, you can say undefined, or the other thing you can say is no slope. It has no slope whatsoever. So I think I'll say it that way. Slope of vertical line, well, I'll say is always undefined, and they'll say in brackets, no slope. Okay, if you have troubles getting these two confused with one another, old student of mine gave me a great way to remember. It's really easy to turn this horizontal line into a Z, which stands for 0. It's really easy to change this vertical line into an N, which stands for no slope. And there you go. Okay? Next day we're going to learn how do you find the slope when you only know the coordinates, like this. What if I gave you these points and I said find the slope, but don't graph it first? That's what we'll be doing next day. Okay? Take care, everyone. Bye.